So today we are going to be talking about intermolecular forces, which is your topic, and then your goal is I can list and describe the three main intermolecular forces. So first, we need to know what forces are, specifically forces of attraction. They determine how easy or difficult it is for gases to coalesce into liquids and liquids to solidify into solids. Or in other words, it's basically how strong the forces are in the atom that makes it act like it does. Or it determines like the boiling point or how strong it holds its stuff together without changing the way it acts. So the two types of forces, you have intermolecular forces, which is what we're going to be talking about today. That's what happens between the molecules themselves. We have talked about intramolecular forces, which happens within the molecules. Those are all the chemical bonds, the ionic, covalent, and metallic bonds that we've talked about so far. There are three types of intermolecular forces. You don't have to write them down right now because we will be later on. There's London dispersion, which is sometimes called induced dipole, but it is the same thing. The second one is dipole-dipole force, and the third one is hydrogen bonds. So here in your digital notebook, if you look at your next slide, you notice there is a chart. Well, the first column is the strength, and we have this information right here for you to fill in. So you need to know that the London dispersion is the weakest. So in this slide or this section, you would put the weakest for London dispersion. Dipole-dipole is stronger, and then hydrogen bond is the strongest. So that's what you need to put in that section. And then from now on, I'm going to be giving you guys the definitions for each of these. You will write these in the definition column. So for example, in the London dispersion column, you need to put what's underlined right here. So London dispersion forces results when there is a momentary shift in electron density within the molecule's electron cloud. So basically, it is just for a brief second becoming polar. So think about a battery. It has a positive and a negative end. Well, some molecules naturally don't have poles. They're just kind of the same all around. But London dispersion forces cause it to sometimes briefly have a pole, depending on where the electrons are located and such. Which is why this is the weakest. Since it's just temporary, it's not permanent, it is the weakest force there is. Okay, dipole-dipole. So this is what you'll put in the definition portion of dipole-dipole on that practice page. It's molecules that have permanent dipoles and are said to be polar. The forces that appear with permanent dipoles affect the strength of the force. So London dispersion was just temporary. It wasn't always polar. Dipole-dipole forces are always polar, which means it always has a positive end and it always has a negative end. And then for the last definition, you need to write down that it is a dipole-dipole, but it is so much stronger than every other dipole-dipole, then it kind of gets its own thing, its own name. And it only exists when a hydrogen atom is present and it's bonded to either a nitrogen, oxygen, or fluorine atom. So you should have this chart filled out with those definitions, and that is the last set of notes for this digital notebook. If there is anything that you have struggled with or anything that you just do not understand, let me know and I can schedule a Google Meet with you to help go over it. I can look over your practice pages and check your answers if you just need a confirmation that you're doing it right. Anything that you need help with, please let me know. I'll be happy to help.